Okay guys, this is 12.6 surface area and volume of a sphere. Are you crazy, or is this the last section of the year? Yes, it is, last section. So, surface area of a sphere, here's your sphere, I drew it as best I could, a little flat there. With a radius r is 4 pi r squared, okay? That is how you find the surface area, the outside of a baseball, which I love, basketball, whatever, soccer ball, softball, etc. The volume of a sphere is 4/3 pi r cubed. So remember that surface area is square in nature because it's area, inches squared, centimeters squared, yards squared, where volume 4/3 pi r cubed is inches cubed, centimeters cubed, yards cubed. Okay? So from there, take those two formulas and let's do some problems. So the first example, I'm going to zoom in and over. There you go. It's a little bit blurry. I don't know why it came out that way. Find the surface area of the sphere, round to the nearest tenth, so that it kind of moved it off. I don't know why it did that. That's just strange. So it did. It's supposed to be correct. Weird. So the surface area is 4 pi r squared. So we put in 4 pi. Your radius is 6, so 6 squared, and you're done. Surface area is rounded to a tenth is 452.4. Really easy. Now, what I want to talk about are these three things. This is called extension. Okay, extension of spheres. So a plane can intersect a sphere in a point or in a circle. If the circle contains the center of the sphere, this intersection is called a great circle. The endpoints of a diameter of a great circle are called the poles. Okay? So here's how it intersects a point. Here's where it intersects. If it just slices it, there is a circle, smaller circle. And the great circle is when it intersects the diameter, and there's your two poles. Since a great circle has the same center as the sphere, and its radii are also called radii of the sphere, it is the largest circle that can be drawn on the sphere. A great circle separates spheres into two congruent halves called hemispheres. Oh gosh, going crazy. Hemispheres. All right, so you're going to do a problem like that right now. So it says find, let's see if I can focus this. I don't know why it's not focusing. Focus, there we go. So it says find the surface area of the hemisphere, that part. So you got to be careful on this one because you're going to see something. Find the half of the area of the sphere with a radius of 2.8, then add the great circle. So you got to have the top, and then you got to have that other side, which is the hemisphere. Okay, the area of that. So we're going to go 1/2 4 pi r squared. So half of the surface area, and with a radius of 2.8, plus we're going to add in the pi r squared for the area of the great circle and the underneath, okay, part. Okay, so when you do that, it's pi times 2.8. When you put those two together, you get 73.9 square centimeters because you're dealing with surface area. Okay, and that's how you do that one. You have that one, I think, in one of your homework assignments. All right, let's do these two problems. So find the surface area of a sphere if the circumference of the great circle is 5 pi. So that's different. Circumference is 5 pi. So what do? First, find the radius. The circumference of a great circle is 2 pi r. Remember, circumference is 2 pi r. So we'd say 2 pi r equals 5 pi. Okay? Divide by 2 pi, both sides, to solve for r, and you get the radius is 2.5. That shouldn't be hard for you to understand. From there, put 2.5 in for your surface area, 4 pi r squared, and put 2.5 in for the radius, and you get 78.5. So this part you should be able to understand how to find the radius given the circle. Okay, right here. All right, next problem, easy. Surface area of a sphere given the radius, substitute the radius, simplify, and you're at millimeters squared, 633.5 millimeters squared. Okay, let's come up and do the last problem of the year. Last problem of the year. Here we go. The soccer ball globe at the right, constructed for the 2006 World Cup soccer tournament, takes up 47,916 pi cubic feet of space. Assume the globe is a sphere. What is the circumference of the globe? Okay, so we got to find circumference. So this is a little bit more in-depth problem. Okay, so you need to know that the volume of the globe is that. The circumference of the globe is the circumference of the great circle. So first use the volume formula to find the radius, then find the circumference of the great circle. So we go volume equals 4/3 pi r cubed. We put in our volume, 47,916 pi. We solve for r. How? Multiply both sides by 3/4, the reciprocal, divide by pi, and then from there, we got to take the cube root of 35,937. Now, on a graphing calculator, where is that? The cube root is found in the math key. So here's your math key. If you press the math key right there, okay, so I'm going to clear that just so you get the whole, let me zoom out here. So we go math, the cube root is right there. Fourth one down, enter, and we want the cube root of, let me slide over here so you can see the whole thing. Cube root of 47,916, no, 35, already did that. 35,937, okay, and we get 33, okay? Any questions on that? Ask me or figure it out. Email me or text me. So the radius of the globe is 33 feet. So the circumference is going to be 2 pi, so 2 pi times the, times 33, or 207.3, okay? So the solution, oh, they're just checking it. So 207.3 feet. So you'd have to know, on that problem, how big an area you need for that. All right, I guess this is the last problem, last two problems. I was getting all excited about the last problems of the year. All right, let's come down here and do this. Sorry, zoom in a little bit. Come on, clear up. All right, let's see if I can get this one in focus. Sorry about that. All right, that's pretty good. I think that's square. I'm gonna go like that. Okay, so let's find this. A sphere with a great circle circumference of 18 pi centimeters, okay? So first thing you do is put 18 pi in for the circumference, and you solve for r and you get 9. Now you substitute 9 in for your volume formula, and you get 4/3 pi times 9 cubed, or 3,053.6 cubic centimeters, or centimeters cubed. All right, last problem. So in this case, we're going to go 4/3 pi r cubed, so 4/3 pi times 11, because that's half of 22. So if I go 4/3, so slide this out. Whoa, I'm crashing and burning. Whoa, look out. Okay, zoom out, Mr. Doyle. Crashing and burning. My last problem, I'm crashing and burning. 4/3, so alpha F1, 4/3, make a fraction. I always love making that fraction. 4/3 pi times 11 cubed caret 3, remember? Enter. And you get 5,575.3. 5,575.3. 5,573.3. Please tell me what I did wrong on that. Feet cubed. And you can get another extra credit point. I just did something wrong. The answer was 5,575.3 cubic feet. Please tell me what I did wrong. Get an extra credit point. This is the last problem of the year in our notes. This may not be correct. If you write down the right answer in your, let's see, we'll put that in your homework. You got to put that in your homework, right? Or the bell work, or wherever you put it. I'll find it, okay? What's wrong with this? Question mark. Mr. Doyle just did something wrong. Last problem. And we're 10 minutes in. So did you watch it for 10 minutes? I don't know if you did. I want to go. Okay. I have to go. You guys have been awesome. Amazing class, I'm telling you. Most amazing geometry class I've ever taught, I think, in my career. And that spans almost going to be 38 years. All right. Well, have a great day. Peace.